Hello everyone, welcome to yet another topic of decimals. Today we are going to do comparison of decimal numbers. So before we start comparing, let's refer to this place value table. We have a whole number or integral part towards the left side of a decimal point, and towards the right side of a decimal we have a decimal part. The places in the whole number are exactly same as we have learned till now, that is ones. This is your decimal. See, immediately towards left we have ones, tens, hundred, thousands, and immediately towards right of decimal we have tenth, hundredth, thousands, and so on. So whenever we have to compare any decimal number, we start comparing from the left side. This is because they are in the decreasing order. This is the highest place, then they are in the decreasing, and this side it is the lowest place. So that is how we compare. Let's see with the examples. We start comparing decimal numbers from the integral part, because left side I said left side is an integral part as it's greater than the decimal part. So we have to observe the integral part of any number before we go on to the decimal part. 12.3 we have in first number and 21.2 in the second number. So integral part of my first number is 12, whereas it is 21. So no need to look for the decimal part. I can simply decide with this that 21 is greater, so I'll put a greater than sign. Refer one more example. I have 1.234 and I have 11.3. So 11 in the integral part and 1 in the integral part. So 11 is greater than 1. Now just check out, the second number is greater, but if you just look at the decimal part, we have single digit over here and we have 3 digit over here. So that is where the confusion lies, that looking at these numbers, that this number seems to be bigger, we can't decide. We have to see the values. So integral part, as we decided, we will compare integral part first and then decide. Now let's see what happens if my integral part is going to be the same or equal. Then how should we compare? We have to look for the 10th place then. Now 12.3 and 12.03. Now see, 12 for the first number in the integral part, 12 for the second number in the integral part. So now I will move on to my 10th place. So immediately after decimal, we have 3 over here, and immediately after decimal, I have 0 over here. 3 is bigger than 0. So I have decided that my left side number 12.3 is bigger than 12.03. Refer another example over here. 3.45 and 3.5. So 3 and 3 are same. We move to the 10th place. We have 4 over here and we have 5 over here. Since 5 is greater, so I have decided this side number is greater. So same way, when integral part and 10th place all are same or equal, we will move on to the next place. Which is my next place? 100th place. See, 12.345, 12.32, 9. So 12.3, 12.3. So it is same till 10th place. So I'll move to 100th place. I have 2 over here and I have 4 over here. So 4 being bigger, this side number is bigger. 3.456 and 3.46. So 3.4 and 3.4 same. The 10th 100 place 6 is here and 100 place 5 is here. 6 is bigger, so this side number is bigger. So same way I keep on deciding. If the number is equal till 100, I'll move on to the 1000 place. So remember, from left to right, we keep on shifting. Now once we have understood how to compare the numbers, we can move on to the next topic, topic 5, how to put our numbers in ascending and descending order. So I would just tell you one thing, that if you keep it like this, that we change all the numbers into like decimals first before comparing, before addition, before subtraction, ascending or descending, there are less chance of the errors. So make it a habit. I have these 4 numbers: 12.45, 3.789, 21.0 and 3.798. So the maximum number of digits in decimal part we have over here is 3. So accordingly, I have put my zeros in all the numbers. Now see, it has 3 digits, 3 digits, 3 digits and 3 digits in the decimal part. So after that, what I have to do is, I suggest that we write our ascending or descending order in a vertical way, neatly like this. It's easy to comprehend and compare for you also. You can pick out the mistakes. See, they are clearly written. We can see 3.78, 3.79. Obviously, this is greater. And then 12 from the integral part and whole number. Easily we can compare and find out our mistakes as well. So ascending means the smaller number first, bigger, bigger and the biggest. And descending is the opposite. So we start with the biggest number and then the smaller and then the smallest in the end. See, these two numbers, 3 and 3 same at the whole number, 7 and 7 same at the 10th place. The difference was where? At the 100 place. We have 8 and we have 9. So this decided which one is smaller out of these two. So after ascending and descending order, we have one more thing to go, and that is, when we can write decimal numbers like this, we can easily see and compare, as I already said. Then we will move on to our last topic for today, conversion of a decimal to a fraction, which is really very easy if you just remember few of the steps. See over here, we have an example 0.15. It says create the top. Top means in a fraction, the top means numerator part. So what I have done, I have simply removed the decimal and written 15 as it is. Now, the second step is count the number of digits in the decimal part. 1 digit, 2 digits. So accordingly, I will create my bottom. Since there were 2 digits, I'll put 2 zeros and 1 is obviously going to be there. So my number, which was 0.15 in a decimal, has been changed to fraction 15 upon 100. Now see again an example. We have 3.4. So remove the decimal from between, write the digits together. 34 as numerator, 1 digit in the decimal part, so we will add 1 0 in the denominator along with 1. So it means how much will be there? 10. See one more example, 1.098. So remove the decimal 1098 as a numerator. Count the digits in the decimal part, 1, 2, 3. So in my denominator, 1, 2, 3 zeros are there and then 1. Similarly, see 20.567, again decimal removed, 20567 written there, and what will be my denominator? 1, 2, 3, so there will be 1000, 3 zeros and with 1 added. Okay, so that's all for today. I hope you have understood how we have to do this. Yes, so now no more. There should be no errors in your work. Okay, so that's all for today.